Hello judges and everyone watching this video. We are Team Mango Tech. In this video, we would like to introduce our product, the Automatic Dry Mango Classification System. In the context of rapidly growing agricultural processing industry, especially among dry mango production facilities in Vietnam, most classification processes are still performed manually. This leads to low productivities, high labor costs, and high risk of human error, resulting in inconsistent product qualities. For small-scale producer, maintaining labor for manual sorting is also a significant challenge. From this real-world problem, Team Mango Tech has researched and developed an automated dry mango classification system designed to make the sorting process faster, more accurate, and less labor-intensive, while improving the consistency of the final product. Our system aims to help small and medium-sized businesses access the modern technologies in a practical and cost-effective way. And now, we will move on to a detailed breakdown of the components that make up our automatic dry mango classification system. Each module plays an essential role in ensuring accurate recognition, stable operation, and seamless product handling throughout the process. The third component is load cell weight sensor module. This module is responsible for measuring the weight of each dry mango slice placed onto the system. Next is the Arduino hardware, which functions as the microcontroller responsible for receiving and processing signals from the load cell. It acts as the communication bridge between the sensor system and the main control unit. We then have the mango tray, the designated container that holds a dry mango slice during and after the classification process. Another vital component is the RC servo motor, which is used to mechanically redirect each mango slice into the correct tray. The system also integrates an autofocus PC webcam positioned at the top view, allowing it to capture high-resolution images of the dry mango slice from above. In addition to the top camera, a side view webcam is installed to capture the thickness and the edge profiles of the mango slice. At the core of the system is the Raspberry Pi 5, which serves as the main processing unit. It runs the machine learning models, receiving sensor data, analyzes images from both webcams, and makes real-time decisions for classification. Finally, the conveyor system is a mechanical backbone that transmits mango slice through the entire workflow. After understanding the individual components of the system, we can now see how they work together to form a complete automatic classification workflow. In the next section, we will walk through the entire operating process from the moment a slice of dry mango is placed onto the conveyor to the final stage where it is automatically sorted into the correct tray. This step-by-step explanation will help illustrate how the sensors, cameras, processing unit, and the mechanical modules coordinate in real time to achieve accurate and efficient classification. Now, let us move on to the operation workflow of the automatic dry mango classification system. LC stands for load cell, and the system uses two load cells for classification. On the screen, we can see the current readings of both sensors, which are at 0 rand when no mango slices are placed in the trays. This section shows the total number of mango slices that have been assigned to each load cell. At the moment, both LC1 and LC2 have a count of 0. This part of the interface displays the predicted weight of each dry mango slice after being scanned by the two cameras. The prediction maintains an error margins of less than 10% compared to the actual weight. Here is the side view camera interface, which captures and analyzes the mango slice from the side. And this is the top view camera interface, which captures the mango from above in the same way. let's begin testing. First, we play a mango slide with an actual weight of 9 grams onto the conveyor and weight is the camera scan and calculate its weight. The predicted weight for this slide is 9.8 grams. At this moment, both trays are still empty with 0 slices inside. Next, we continued with the second mango slide, which also weighed 9 grams. The system predicted this slide to weigh 9.1 grams. Since tray 1 currently contains 9 grams slide, the system will direct the second slide into tray 1 as well. Load cell 1 is currently showing 9 grams, reflecting the weight of the first slide. After the second slide drops into the tray, the weight on LC1 increases. We now move on to the third mango slide with an actual weight of 4 grams. The predicted weight for the slide is 4.6 grams. Tray 1 currently holds 2 slices, and since LC1 has not yet reached its full threshold of 20 grams, the system continues directing the third slide into tray 1. After the third slide falls into the tray, LC1 becomes full. Next, we test the fourth mango slide, weighing 8 grams. The predicted weight is 8.8 grams. Since tray 1 has already reached full capacity, server 2 activates and directs the slide into tray 2. After the fourth slide drops into tray 2, the reading on LC2 increases to 8 grams. We then proceed with the fifth slide, which also has an actual weight of 8 grams. The predicted weight is 8.9 grams, and the slide is rotated into tray 2, since tray 2 has not yet reached its full capacity. If both trays become full, the next mango slide will automatically be sent to the end of the conveyor. Finally, we have a mango slide that fails the shape quality requirement, and the system mark is as a not qualifies. This non-qualified slice is sent to the reject trays at the end of the conveyor. In summary, the automatic dry mango classification system developed by Team Mango Tech demonstrates how modern technology can significantly improve the accuracy, efficiency, and consistency in agricultural processing. We hope that through this demonstration, you have gained a clearer understanding of how each component works together to create a complete, intelligent, and highly practical sorting system. Thank you for watching our video. We are Team Mango Tech, and we look forward to continuing to innovate and bring more useful technological solutions in the future.